friends, for those of you missing class today, here's what we did. So take a pause and go ahead and see if you can try this out. This should be review for you, and check back in when you're ready. All right, so if we're taking a look and we have to write a linear equation, remember we need to know the slope and the y-intercept. So looking at the graph, we can see that our slope is a -1/2. So we have y equals -1/2 x. And as far as for finding the b, like if I go up 1 and over 2, it's not going to connect. So we could estimate it, but we have a point. So let's go ahead and plug it in. We know that when we plug in 3, we're supposed to get out a 1. So we're trying to find that b value there. So if we go ahead and work that out, we get -1.5. So that means that if we add 1.5, we get 2.5 for our b value. So that means that this equation right here is y equals -1/2 x plus 2.5. All right, and now for our blue, we can see that this is a quadratic, is a piece of a quadratic. And I gave you this format. Remember, this means that's your vertex. And this a value lets us know if there's a stretch or not. So our vertex is -2, -1. So if we can go ahead and start off, we're not sure if there's an a value. But if I'm subtracting a -2, it's going to become a plus. And minus, that's a -1. I mixed up my x and my y. Okay, and -2. So we do want to test to see if there's a stretch on there or anything like that. So we can pick any point. I can plug in. When I plug in -3, I'm supposed to get out a +2. So if I plug in -3, I'm supposed to get out a +2. So I get 2 equals -3 plus 1 is -2. -2 squared is 4. So I have 4a minus 2. And when I go to solve, I'm going to find out that my a value is 1. All right, so there's no stretch on there. So my final equation is just y equals x plus 1 squared minus 2. Now to review for domain and range, okay, the domain for the red one, all right, remember it's your x values, okay, and so we can see that this red line is between 1 and 6, and you can't really tell because the blue is over it, but so our domain looks to be, our x value can be anything in between 1 and 6, but it can also be equal to it because it's colored in. So that's our domain. And the range is the lowest value that it goes to the highest, and so that's our y value. So the lowest value goes here. Now I could plug in 6 into my equation and do the math and find out what that value actually is, but it is actually here it's -1/2. So the lowest that this goes is -1/2. And the highest value that it goes is to 2. So that's our domain and range, and just a reminder about how to read those on a graph, all right? All right, so now let's take a look at the quadratic one here. All right, so this does come to an end. There's no arrow, so we are going to have sort of this boundary line here. So in this case, our domain is the x values can be anything in between -4 and a +1. Now remember, you can write it as an inequality, but you can also write it in interval notation, which is -4, 1, and it's with the brackets because the values are both included. Now for the range, the lowest it goes is -2. I'll do this one in interval notation instead of inequality. -2 is the lowest, and the highest it reaches, and my graph got a little cut off, is a 7, and it's colored in dots, so it's going to be included. So hopefully that helps remind you about the domain and range and how to approach that. And so this is actually an example of what we are doing today in class, which is what's called a piecewise function. And a piecewise function is just that, right? It's a function whose value is defined by different expressions in different intervals, right? Right here, from here to here, it's a quadratic. From here to here, it's linear. So we're going to take a look at that here in our notes, okay? All right, so piecewise is putting together all of these different things. So like I said, a piecewise function, all right, is, and you can look up the definition in your book there. Just, I don't want to take the time to write that there. But it's a function whose value is defined by different expressions for various intervals of its domain. And so what that means is, if we take a look, this is how you write it. Look, like this is how that's written, okay? It's a series of different rules, right? Each graph is made up of a different part. And so, for example, x plus 3, that's this line right here. And it has to meet these qualifications. Notice it's defining the domain. We follow this rule until we get to -2, and we see this open circle. So we can't equal that value, but we can equal anything. If x is any value less than 2, we're going to follow this rule. Whereas if we pick any value between -2 and 2, then we're going to follow this rule, x squared. And then another function is just this one. Notice there's no x there because that's a constant, right? If we have a horizontal line, that's really like just saying y is equal to 1. And so that means that our output is always going to be a 1 no matter what the x value is, as long as, like, if it's between 2 and 5. So if I said, if I asked you, what is f of 4? Well, I'm not going to plug it into this one because this is only when x is less than -2. I'm not going to plug it into x squared because it's only for values that are between -2 and 2, and 4 is not between that. So when f is 4, and I can even see here on the graph, 1, 2, 3, 4, I can see that the output is 1. And so that's what that means about how we go about evaluating piecewise functions, right? We have these different rules, and it can be 2, it can be 3, it can be 4. It can be a variety of them. So if we're trying to evaluate a certain value, we have to figure out, well, what section, what interval is it going to fall in? And that's the rule that I need to follow. Okay? And so we've actually, absolute value functions are actually a piecewise function because technically, right, it's this value here, right? We're going down, and then here we're going up. So if we wanted to, we could write this as a piecewise function, like the absolute value of x. Well, here's what it really is equal to. It's f of x is really equal to the value of x if x is greater than or equal to 0. So, right, what's the absolute value of 3? It's 3, okay? But it's negative. If you plug in a negative x, then that means we're going to put in the negative value there for when that is less than 0. Okay, all right. So again, this just is telling us, like, right, this is saying, hey, this is the same as a linear equation of 1x plus 0, right? The y-intercept is 0. The slope is a positive 1. Whereas here, this one, we have y equals -1x, which is a -1 slope, and our y-intercept is 0. So that's where that idea of this piecewise is coming from, but we just have another way of writing that, which is the absolute value function. All right, so do me a favor, now that we've kind of talked about domain and range with the warm-up, you can go ahead and pause this video and see if you can identify the domain and range for functions a, b, and c. Come back when you're ready. All right, so here we go. I've written the domain and range for these in a couple of different ways. So as an inequality, you might sometimes see it written this way, where it's this bracket. And this just means, so here this x is just saying, hey, my x values, and we put a little line there, and you then write it in inequality notation. All right, so again, if we go to c, it can be equal to -4, and it goes all the way to 3. Okay, and the same thing for the range. We can do it in inequality notation, and typically this is the way it looks. It's just saying, hey, our y values are going to fall into that range there, the lowest being 2, and then up to 6. All right, for B, I chose to do, for the domain, interval notation. Now, notice that my domain is not continuous. There's an or statement here, right? So that or statement is because notice right here, there's a gap in the values. There is no x values in between right in here. So that means that my first set of x values is between -6 and -1, or I can pick between these two values. And then again, notice that I put a parenthesis versus a bracket because it's an open circle. It's leading to 5, it's approaching 5, but it never quite gets there. Okay? And now the thing with the range is that it's either 2, right? This is all 2, and this is all 4. Like it's either 2 or 4. So you'll see that I just did the little fancy brackets, okay? And I just listed out the 2 values that the range could be. So you really have to kind of distinguish, like, am I just listing certain points, which is when I'm going to use like this set bracket notation, right? If it's an interval, like we have for the domain here, you can write as an inequality or in interval notation, right? And then here we have C. I kept it in interval notation. I just like it. It's a little bit easier. You don't have to worry about which way your inequality signs go. But you do have to be mindful of the gaps. So just make sure that there's no gaps. So if we're going this way and I move across, right, you might say, well, there's an open spot right here. Yes, but this part of the graph covers that. So this value, 1, when x is 1, is taken care of by this quadratic down here. All right, and then it picks up and it goes to this point right here, which is an open circle. So that's why we have a bracket on there for the domain. All right, and then the lowest value that we start at is -3. Again, we want to kind of drag our pencil horizontally up, kind of looking. Again, we do see a gap happen right here, but if we were to scroll across, we can see there is a y value right in this area right here. So it's covered. We don't have to do an or statement. There's no gaps, okay? And we keep going up, and again, there's a gap right there, but again, this quadratic portion of the graph is covered, so we can continuously go, right? All of these y values are taken care of, are accounted for by either the quadratic portion or the linear portion, okay? So that's how you interpret the domain and the range from a piecewise function. All right, now we're going to go ahead and take a look at how to graph these. Okay, and then we'll go ahead and state the overall domain and range. So I'm going to go ahead and zoom back out so we can fit the graph and this. So essentially what it is that you have 3, in this case we have 3 different equations. So for example, we have, there's that one, there's an x plus 1, and there's a -x plus 4. So essentially what we want to do is, this is kind of like what we have right here. We have y equals a -3. We have a y equals, oops, that's really large. We have a y equals x plus 1. And then we have a y equals -x plus 4. So those are the 3 different equations that we want to graph, but we have some parameters, okay? So here, this is a horizontal line, this y equals -3, but it's between -5 and -2. So I'm going to go to -5 and -2 on my graph, and I know that the y value is always going to be -3. So I know that at -5 and at -2 and everywhere in between, my output is -3. Now, notice this inequality, it has to be less than. So I'm going to change that circle to an open circle. And this one is a closed one because it can equal -5. All right. Then I'm going to go to x plus 1. Well, again, my boundaries are -2 and 1. So just plug in when x is -2, my output is going to be -1. So that gives me my furthest point left, and then I plug in 1 and I'll get my furthest point to the right. So I have, when I plugged in -2, I got out a -1, and that's a closed-in circle because of the equal to sign. And if I plug in a 1, I'm going to get out a 2, but that's going to be an open circle because it doesn't have that equal to there. And that's how we're going to go ahead and graph those. So no matter what the graph is, we're just going to put in those endpoints. So if I plug in 1, -1 plus 4 is 3. So when I plugged in 1, I got out a 3. And when I plug in a 4, I end up getting 0. And that